Hi, everyone. This is Gary Berman, host of the Cyber Hero Adventure Show, and we have a special briefing today with Abby Kukura, who's going to talk to us about the National Action Plan for U.S. Leadership in Biotechnology. She's the Associate Director for Platforms at the Special Competitive Studies Project. Hi, Abby. Welcome to the show.
Hi, Gary. Thank you so much for having me.
Indeed. I'll begin with something I usually end with. Thanks for who you are, for what you do, and most importantly, why you do it.
Thank you. Likewise.
Thank you. So why don't you share with us, our audience, about the SCSP and some of the cool work that you're doing over there. I originally learned about you and had some great experiences on your National Security Report on Artificial Intelligence, which was prescient, I think, to put it mildly, wasn't it?
Yeah, you're absolutely right there, Gary. So I can start with a little bit of an overview of the Special Competitive Studies Project, which is essentially a 3-year project that is developing recommendations for U.S. tech competitiveness in the 2025 to 2030 timeframe. SCSP has a near history and a far history that are worth just providing a short context on. So the near history for SCSP is the National Security Commission on Artificial Intelligence, which was a congressionally mandated commission to study the impacts of AI on national security. Eric Schmidt, the former Google CEO, was one of the chairs of that commission and felt at the end of it that there was a lot more work to do. And his executive director of the commission, Ili Barakhtari, was game to do more and work on other emerging technologies, looking sort of at a longer time frame and more broadly at U.S. competitiveness. So that's the near history. And around the same time, Eric was writing a book called The Age of AI with Henry Kissinger. And Henry Kissinger mentioned a project that he led in the 1950s called the Special Studies Project, which was sort of at the end of World War II and the onset of the Cold War, looking at how democracy had to reorganize for that era of geopolitical competition, and one in which technologies were changing the way we had to think about things like foreign policy, defense, the economy, et cetera. So Kissinger told Eric, I think we need something like that today, given all of the technologies that are reshaping the future of democracy, of geopolitics, and the importance of technology being an organizing principle for this decade and beyond. So with those two combined histories, SCSP started its 3-year mission in October of 2021. We're about a year and a half into it now. And we're a nonprofit project working on those topics.
Indeed, and there are so many different sectors, that your team, works on. And one we're going to be talking today, of course, is on biotechnology, which we could talk forever about it, just because of the nature. I had the privilege of reviewing the report, and it is really just kind of mind-bending, the kinds of topics that you've decided to address. How did you decide on biotechnology as your next endeavor?
It's a great question, and maybe something I could have added about SCSP is that we are broken into sort of 6 lines of research. So modeled after the way they structured the project in the 1950s, we're looking at foreign policy. We have a team studying foreign policy, a team focused on defense, one on intelligence, one on the economy, one on society. And then the team I'm on is tech platforms, which is sort of looking across all of those and trying to think about what a public-private process for national tech strategy would look like and how to develop action plans for the most critical technologies on the timeline of this decade. And that is sort of how we arrived at biotechnology as one of 6 general purpose technologies that we concluded in a report we put out in September are going to be the primary drivers of innovation and therefore competitiveness over the next decade. So we're really thinking about sort of the general purpose buckets that will drive all sorts of innovation, both enabling one another, converging, and driving sort of the next general purpose leaps in humanity.
You know, one of the interesting things that you've just said right now is this notion of public-private partnerships. You know, and all the listening and learning that we've done over the years from cybersecurity and technology thought leaders, one of the interesting things that that I've taken away, and see if this applies to your thinking, which is, you know, sort of the threat actors. I'm just aggregating, you know, these divergent, you know, motivations are kind of horizontally structured, you know, where they share information, you know, quite freely and quite readily. The defenders, you know, are more vertically structured because of competition, of rules and regulations, you know, state, local, federal, global, you know, sorts of constraints, things like that. Help our audience understand the importance of information sharing and the way that your organization propels that.
It's a great point about how systems and structures can sort of drive the way we do innovation. And I think that is really getting to a point about why SCSP feels like we can play a role in helping organize the US for these technology competition arenas. And that's because I think these technologies that we're thinking about with their general purpose nature, they're bigger than either government or the private sector could do on their own. And there's a lot of goodness happening sort of across our innovation ecosystem, but it remains ungathered and can be better integrated with sort of a strategic lens on what is happening, what are the gaps, how can we help fill the gaps and help stitch together pieces of the ecosystem that might not even know one another exists. So I think that sort of information sharing occurs to some degree naturally, but in the context of an international competition, we can't leave it to chance in the technologies that will really be critical this decade.
Indeed. So that leads us into biotechnology. You know, you had written, your team had written that the U.S. leads in, you know, biotechnology today. So help our audience understand why an action plan is necessary.
Yeah, that's a great point. And I think it's really important to acknowledge that the United States does lead in biotechnology today. Our ecosystem is really on the driving edge of technological breakthroughs and on identifying novel ways to approach biotechnology, ways to apply things like AI in biotechnology, et cetera. But when we're talking about biotechnology, we're dealing in the domain of atoms and cells, not bits, not the software innovations that we've seen in the past few decades where advantage can kind of come naturally, or it can come through the private sector alone. But it's much harder to try to do that in the domain of atoms and cells. It takes much longer to see innovation scale. It's much harder to sort of commercialize technologies. There's complex regulatory structures and just really a whole set of variables across the ecosystem that you need to get right to translate pure technological advantage into durable ecosystem advantage. So with the difficulty of making this technology work and unlocking its general purpose potential, plus the urgency of the international competition, where we face an international rival and that doesn't share our values and has explicitly stated that it wants to lead in this technology, is putting a lot of resources into leading in it and would like to supplant the US as the world's global technological superpower. We can't really leave that leadership to chance, and we need to organize our ecosystem to translate the amazing things we're doing today into something that will last and can scale domestically and with our allies and partners.
Indeed. And just recently, or I think this was on 60 Minutes, I just saw actually yesterday about kind of solving the proteins, right? And the company that I think led the charge or did that, actually made it, kind of open source and public. When I saw that, I was thinking, gosh, I'm not sure I'd be so quick to have our adversaries be able to see, this information. What are your thoughts about that?
Yeah, I think it's a really good point, and that we really face a choice today about, do we want to lean into open source in really everything from AI to biotechnology to other technologies? Like, which will benefit our ecosystem more? Is it leaning into the open source dynamics if our ecosystem might sort of be predisposed to success in that arena in the same way we have been with open source software? Or if a closed model is more to our advantage, I think I lean in the open source direction. If we apply sort of the logic of software, that if you create this sort of self-improving ecosystem, the benefits that accrue to that could outweigh the challenges of it. But I think it's a really critical question that we need to keep studying. And at the very least, if open source is in some ways inevitable, or there will be a piece of open source, we need to understand what the potential risks are.
Indeed. And of course, we would want to, think that through regarding the rapid adoption of AI and solving some of those problems. What did this report look into that quite a bit?
Well, while this report was focused on biotechnology, I think AI was sort of a really important technology to be thinking about as it relates to biotechnology, because I think AI is not only an enabler of biotechnology, but the convergence of the two of them, I think, accelerates the potential and the timelines for advances in this technology. So a lot of the tech moonshots we came up with, as well as the policy moves, are really thinking about how AI and biotechnology are going to intersect. And just to provide one example of specifically how they intersect is on data. Because if you want to really be able to use AI for biotechnology, you need to have a strong corpus of data with relevant inputs to be able to do things and sort of apply AI to this domain. And you see that with things like the protein folding, that the ability to draw on a database has sort of unlocked all these incredible capabilities and helped us sort of understand the protein structure of the universe better. And there's probably a lot more that we can do, but we need to get the data inputs right to be able to do that.
Indeed. And so let's unpack just biotechnology, because it encompasses so much. How did you and your team prioritize what you were going to be looking into? And then we'll follow that up with, some of your recommendations.
Absolutely. I think maybe the one thing I'll say about our approach to the biotechnology plan that I think really informed what we looked at, who we talked to, what we asked in developing the action plan was what is sort of happening in the private sector, that while government is also studying these issues and trying to come up with plans itself, how can we help build on what government is doing, and how can we convene the private sector and sort of bring the leading edge of innovation into the conversation to sort of have the leading edge of technology meet strategy. So with that in mind, we saw the benefit or the value add that we could provide as our ability to convene the private sector and come up with a set of tech moonshots that really would, if achieved, raise the bar on what our innovation ecosystem can achieve in biotechnology, setting bold goals that seem pretty stretchy, honestly, if you look at them in isolation. But if you take a moment and think about them and look at sort of where leading edge of technology is today. And if we really got our act together, organized in the right way, we could do this. And the impact would be to unlock the general purpose potential. So the structure of this action plan and any tech action plan that we put out is this set of tech moonshots that would add up to the level of analysis of technological advantage. And then the second level of analysis is policy. So what are the policy variables that we need to get right to make that work? What are the right levers to pull? What is the appropriate role for various actors in the ecosystem, from startups to national labs to the university ecosystem? There's really a role for everyone in it.
And are there, going back to this kind of horizontal versus vertical kind of matrix that I was thinking of a little bit earlier, what thoughts do you and your team have about kind of breaking down those silos, getting people, for lack of a better way of saying it, to play nice?
Yeah, I think that's another great question. I think something that we put in the biotech plan and is probably a piece of every action plan is recommendations for the innovation ecosystem. So these are specifically targeted at sort of what is the minimum viable set of ecosystem moves that we need to make that better stitch together these things happening on a horizontal plane that aren't necessarily integrated vertically. And our system works in large part because of this amazing stuff that's happening in a diffuse way. And I actually think that diffusion and decentralization is really beneficial for something like biotech, where the technology can theoretically grow locally. A tree has everything it needs to grow from the soil up in one place. It's not relying on some central piece of equipment somewhere. I think the same will be true of biotechnology. So we need to really figure out how to harness that and come up with sort of the right mechanisms for these actors across the ecosystem to be able to connect and sort of feed the right inputs and work well together, but really sort of harness the decentralized and diffuse strengths of the ecosystem as well. So what this might look like is a consortium of national laboratories across the country that are each working on a different piece of a puzzle for a tech moonshot, and the way that they all, the way that this breeds some better synergy and integration is that they all have to feed into the same data platform, for example, but they're all working separately. But how do we sort of leverage the separate but create sort of the connected tissue?
Indeed. So building on your metaphor of a tree, where would you characterize the state of biotechnology at the moment? I mean, is it roots, or, are there little sprouts, or do we have a trunk, and, are there branches, are there leaves? It's a very useful metaphor.
Oh, that's interesting. I wish I'd thought through the metaphor of this layer deeper beforehand. I might have to come back to you on exactly where I would characterize the
you realize
this metaphor.
But you realize what you're doing here is you're saying you want to come back on our show. That would be great.
Yeah, I mean, maybe the early answer is that I think the roots are there, but the trunk, which is really the infrastructure and the sort of core ability to scale these ideas, I think that's the hard part. And that's what will translate it into something that really leverages everything from the roots down below.
Indeed. So let's get to some of the high-level recommendations. Why don't you share those with our audience?
Yeah, absolutely. I think maybe I can just start by giving a brief overview of the tech moonshots. Those are what I'm really excited about in the plan, and I think that's part of what differentiates it from some of the other amazing biotech work out there is we're trying to sort of take all of that and say all of this stuff is really amazing and necessary, but let's think one step bigger and think about what we could really do to make this happen. So the 3 tech moonshots we propose are, first, an annotated non-human genome project. So the Human Genome Project that mapped the entirety of the human genome happened 20 years ago, basically, to this I don't know if day, month, year, but we really need something like that to turn nature itself into a code base. So if we can convene parts of the ecosystem to really develop a comprehensive, we suggest open source genetic library of the entire biodiversity of the nation, potentially one day the world, that would really allow us to create this corpus of data inputs for biomanufacturing. And biomanufacturing, you could theoretically grow through bioprocesses up to 60% of global GDP. So the scale of what you can do if you really have this code base is pretty amazing to think about. So that's one piece, is the annotated non-human genome project as the data inputs for general purpose biotechnology. And the next piece is that we really need to master the ability to engineer biology. So how can we actually engineer the outputs that we're talking about, biomanufactured critical minerals, for example? And to do this, we suppose that if you were to establish an initiative to create a fully synthetic cell, that would force us to really understand biotechnology at the level of the cell, at the cellular level, master the ability to measure, to model, to make at that scale, and really sort of unlock a step change in how we can engineer biotechnology in sort of a routine, reliable, repeatable, and scalable way. So those are the two real sort of technical drivers. And then the third piece is probably the most essential. It's a proposal for a national medical shield that integrates and operationalizes all sorts of pathogen defense, rapid detection, and response capabilities that already exist across the nation. And the way I like to think about this is we need to design out the need for a future Operation Warp Speed. And if you had somebody integrating all of the work that's already out there and consistently working to integrate and ensure our ability to do these things at scale and have these capabilities ready, that would provide the baseline security that we need to be able to step into the world of synthetic cells and nature as a code base comfortably. Because with the immense opportunities that those tech moves allow, there's also risks. But what something like this MedShield would allow is the ability to grow a response to virtually any bio threat anywhere in the world.
One of the most, forgive the interruption, that was one of the most compelling and immediate kind of use cases. If memory serves me, if there was a pathogen detected anywhere in the world, you might be able to embark on having a kind of a draft vaccine. I think it was in 3 days. Did I get that right?
I think that's about what we put in there, which, like, as you say it sounds like a stretchy goal, but I think that's kind of the bar we need to set if we want to go comfortably into this world. And the technology is, if not there already, I think it's on the way.
Yeah, I mean, if you look at the trajectory of how long it took to get a vaccine, just let's say 5 years ago, I guess it might have been 10 years. And, due to COVID, I think the industry did, some miracles, to cut that time horizon way down to, I don't know, 8 months, something like that. So I think the trajectory of that, is aligned with what you're saying and very possible. Well, I could listen to you all day, as I'm sure our audience, could as well. So is there one of these recommendations that you view as being the most important?
I think it's really the one that we're talking about there with the MedShield, because I think there's, when you talk about biotechnology with nearly anyone, they might think about the opportunities, but it's hard to not get caught up in the risks and to not think about, oh no, if this technology is something that will ultimately be in the hands of individuals, how do we prevent somebody from creating some sort of pathogen that could wipe out all of humanity? And so I think we need to get this baseline security system right and do that early, because that will allow us to really focus on and achieve the opportunity side of the equation, which I think is ultimately much larger but the asymmetrical impact of the sort of risk side of the equation, if we don't solve for that problem quickly, we're not going to be able to focus on everything else. And so I think for me, that's really the highest priority item in the action plan.
Indeed. And as we're wrapping up, what would you hope are the next steps, for the action plan, or what would you like to ask our audience to be thinking about or doing? How do they get a copy of the report, for example?
Yeah, I'll start with the last part of that because it's the easiest. If you go to SCSP's website, which is scsp.ai, the action plan should be front and center on the website for now or in the Our Work section. We also have a newsletter called 222, where we announced the action plan and wrote an interesting, I think, red-blue analysis of the US and PRC biotech ecosystem. So highly recommend subscribing to that for those who don't already. And then in terms of what we hope the impact of the plan will be and what we'd like to do with it, I think we really, we never see this as a final document. It's always a work in progress. And I think we'd like to sort of dialogue with anybody working on these issues or who has ideas about how we can move these forward. The last thing we want is for this to just be a paper on a shelf. We want to do what we can within our charitable nonprofit mission to move the ball forward on some of these ideas, and especially where we can sort of help connect the dots between the private sector and government. We're all for that. We've already started building out sort of implementation level detail for some of these recommendations, and really anywhere where there's significant interest, we're game to sort of build out the implementation plans and help get these ideas done.
Indeed. Well, Abby, to you and your colleagues, on behalf of a grateful nation, thanks for who you are and what you do, and most importantly, why you do it. We have Abby Kukura, the Associate Director for Platforms at the Special Competitive Studies Project, and she just gave a fantastic briefing on the National Action Plan for U.S. leadership in biotechnology. And to our audience, stay safe, take care, and thanks for who you are and what you do and why you do it. Have a great day.
Thank you.